that we thought were important. Today, we're going to be talking about building a strategy and how to then put that strategy into action. I'm Doug Davenport. I'm CEO of Prospect Silicon Valley. We and our partners, Ideas Consulting and Alter Engineers, are here to deliver this session. I think we can go forward. One of our speakers has yet to join the meeting, but we're going to catch him up. Q, do you want to go over this?
Yes. So my name is Q. I'm a project associate at Prospect Silicon Valley. Welcome, everyone. We do have AIA credits for this, so you'll have more information about that after this webinar, but these are some of the learning objectives that we have for today. These are our panelists today, like we said, Doug, David, Shannon, Stefan. Just a little bit more about the series. Our goals are to enable you to better communicate opportunities and challenges around carbon-free buildings, equip you with some knowledge, resources to address decarb questions in your projects, and provide you with an understanding of design strategies, priorities, and processes.
Can I hold for a second? I just want to check with our co-speakers. I only see a portion of the slides in the shared screen. Is that an issue for anybody else, or is it only me?
I just see the whole thing.
I see the whole slide.
Okay, then it's only me. That's perfect.
Awesome. Moving on. Just a few notes about today. There's still a lot of things that you can show up for, and this doesn't replace your responsibility to do your own research. Take some time to really build relationships between your clients, because you know the best about your clients' decisions and your other influences and stakeholders that are involved. And the advice we provide you today can be included in your scope and your future projects. Yeah, so just take what resonates and recognize opportunities and networking within what you do.
Okay.
So again, we did say that we had a previous session back in May, and that recording is on our website if you want to review it, if you missed it. Right now we're doing another webinar, Developing a Carbon Strategy, and there'll be more in the future. Like, we really want to hold more events and networking opportunities to reach you all and just build more network and opportunities to connect in person too. So keep looking forward to that. The QR code leads to our website, and you can check out our events on the events section of our website.
And Q, you'll share that link in the chat as well.
Yes, of course.
Excellent.
I'm gonna move it on to Stefan from Alter Engineers for the next section.
Great. Hi, everybody. Thanks for attending. And yeah, I'm Stefan from Alter, partner there with Shannon and Allison. And I'm going to talk about a bunch of things, but kind of involving carbon and energy modeling. And so let's get to it. So kind of the major point I want to drive home today about kind of designing our buildings around lower carbon designs is that early decisions drive bigger impact, as the slide title says. So when you're working on a building, decisions you make early in the project are going to have a much proportionally larger impact on the rest of the project, and that includes like all the carbon that's going to be kind of associated with this building. So I'm pushing people to bring their consultants on earlier in conceptual design, because at this time there's kind of you still have a sort of a blank slate, and being able to make these early decisions with carbon in mind is going to like pay off very highly down the road when you kind of already come into DD, CD with a kind of a lower carbon design already ready. Part of the reason why it's so easy to make these decisions early on is that analysis is much easier. So doing things like energy modeling or looking at kind of embodied carbon modeling, that is a much easier task early on in the project when you're not getting bogged down with other coordination details or loads modeling or all these kind of Revit details. Early on, it's easier to kind of look at the project at a higher level and kind of rapidly iterate, make decisions that have big impacts on carbon. So yeah, that's what we're here to talk about, and ready for the next slide. So decarbonization is design and strategy. So kind of just take a step back. The entire carbon picture of a building tends to be a lot bigger than people may kind of think. I think the slides are kind of zooming in and out a little bit, I'm noticing, but it's probably not a big deal. And I still see like most of it myself. Yeah. So anyways, the scope of carbon in a building is a lot bigger than people might assume, kind of looking from the outside if you haven't like looked into carbon much. I think traditionally a lot of people consider operational to be the part of the carbon sector that's like mostly associated with the building, and you can offset that with like solar and PV and low energy systems, but it actually is a lot bigger than that. And a lot of the carbon that goes into a building is kind of already in the atmosphere before the building's even operating, because you have so much carbon associated with the material production, the transportation to the site, and the construction process. Right. So really, like we're at day zero of a building, you've already accounted for like the majority of the carbon that goes into that building and before it's even operating. So it's really important to make sure we're accounting for everything and not just this kind of tiny operational scope. Other things that teams should be considering is things like so in addition to the operating, it's like the facade, the structure, the actual materials used in the HVAC system, the size of the PV and battery systems. Also, the lifetime of the components being used is pretty important, because every time you have to maintain and replace equipment, that's kind of more carbon being used for the building. So and this can even go down to like manufacturers like giving you faulty pieces of equipment, or maybe a bad design using a piece of equipment that doesn't actually fit where it's supposed to be, and then you have to buy a new one. So that's other things that increase the amount of carbon. Also, the end of life is very important. So how much carbon is being used for demolition, transportation? Are we able to recycle it, or is it just going to waste? So all the different pieces of scope that people maybe don't always think about, and the more we think about it, the lower carbon emissions are going to be associated with our buildings when we design them properly. So next slide. Right, so building up strategy and the design process. So getting back to this idea of kind of thinking in a bigger picture about where all the carbon in our buildings is coming from, and also making sure we're trying to think about it earlier in the project, so we have like more of an ability to design these projects the way we want to be. We're kind of looking at the different phases of design, and this is kind of our what we're showing here is kind of our deal in terms of what the design team, how much time they're spending on the different things in each phase of design, and we've highlighted some lesser kind of thought about pieces like solar PV and energy storage. David, I don't know if you have anything to say about like how we're trying to push solar and energy storage into earlier parts of design and not just like slapping it on at the end in construction documents.
I'll just say that it's not really a lesser thing. It's an important piece of the puzzle, and how you do it, where you do it, and how much you put in is the key strategy that you got to figure out. Earlier is better, of course.
Yeah. And yeah, solar and batteries both, they have huge implications for your energy use and carbon emissions, and as well as your embodied carbon. So we're a conceptual design, and we haven't even picked a massing yet. We're just looking at the siting and orientation and massing. We want to be analyzing what are the implications of that siting and massing, right? But if we're analyzing that in like an energy model without looking at the solar and PV, then we're missing like a big chunk of the picture. So making sure we're like actually like looking at the full carbon picture of a building from the beginning. When it's easier to analyze, it's easier to make decisions. So conceptual, yeah, making a push for like bringing consultants in conceptual when you can kind of analyze every decision based on the carbon impact. But yeah, schematic design also hugely important. This is kind of when the bulk of the analysis happens, because the team's still making decisions. Maybe a massing has been decided and programming, but you're still making decisions on kind of your envelope and which HVAC system you're going to decide on. And all those things still have huge implications for like the solar PV and energy storage. So, schematic is really when we get to make the decisions, because in design development, we want to be developing the design, to have a successful building. We don't want to be kind of sitting there like spinning our wheels on making decisions which HVAC system or what envelope strategy we're going to use in design development. So pushing these things early on. So like in DD and CD, we focus on just making sure, our permitting is going to go okay. We're going to meet all the codes. We're going to meet our sustainability goals, and getting through the VE process. So conceptual and schematic are really where we can make the decisions that affect the carbon. So we can go to the next slide.
Great. So let me start off this slide by saying, let's back up one slide, just for illustrative purposes. Thank you so much. So what we're wanting to make a point on here is that although there's a lot of traditional systems that are looked at in the conceptual design phase, solar PV and energy storage, at least in California and in many other places, is a reality, and it is no less a central part of a building design process than the HVAC system or the windows or anything else. And it's a fundamental part of what the carbon strategy for the building will be. In addition to that, the energy platform you work from is going to drive many decisions down the road, but these are costly and complicated. So when we go now to the slide that I'm going to start on, here's what we're recommending. Now, I just want to be really clear that we as a team and as folks that have lived in this world for a long time, we're not saying you should scrap your design process and forget everything you've learned. We're not saying that what you're doing today is wrong, but we are saying is that you can take a different tack, you can take a different approach and achieve really great outcomes. So things that we feel would be very important, I'm going to have a little bit of discussion amongst my partners here as we move forward. In the conceptual design, while you're looking at all those other systems, really at early stages, working with your client and then also with your project team to set ground rules or targets for embodied carbon, for operational carbon. This may be leading back to an internal standard. It might be leading to a building performance standard for the building once it's built. But setting all of those objectives up front then become a frame for the rest of the project. Certainly setting ground rules for how you can employ modeling and other kind of estimations to run through scenario analysis. We're going to be covering that in a second. And really having clarity on what the goals are with respect to carbon, incredibly important. David, Shannon, Stefan, any points you'd like to make on the day one objectives that we should be encouraging here?
Yeah, I think.
Oh, sorry. Go ahead, Stefan.
Go ahead. You go.
I just wanted to say that I think it's important that all of the players are in the room to talk about, because it's a holistic approach that you're looking at. So you need structural, you need civil, you need everybody in there to even bring up things that could be pitfalls or things that they might see could happen. Go ahead, Stefan.
Yeah, I was gonna say, just getting client buy-in is really important. You need to make sure that your client is involved in the conversations, because they're the ones spending the money, and there's a lot of different motivations, and like being ready for future like more stringent carbon targets and building performance standards is important. But if your only motivation is like meeting your architecture 2030 goal, there's a chance your client might not be totally aligned, at least not totally aligned, without some kind of walking through and understanding like how these targets were even set, and benchmarking, comparing to existing existing buildings, it's a great way to kind of help clients see, what's already out there, how they can beat that, how much they can beat it by, and using modeling to kind of show them how attainable it is to be much better than the existing buildings.
Got it. David, any thoughts?
Yeah, no, Shannon and Stefan nailed it, I think, starting early on, thinking about holistically about decarbonization at the beginning of the project and setting those goals is key.
Excellent. Yeah. So, I mean, your clients are going through a lot. We're seeing ownership go through a lot of challenge, especially with regards to things like building performance standards and other regulation. But there's also the fact that, frankly, just now the economics of the sustainable choices become far more complex. It's best to get everybody out onto the table and figure out what direction you're going to be going. So if we just go through these, and yes, you could read the faint versions. We're not trying to hide anything, but let's go to the next set real quick. So based on what you know from the beginning, and I'll just also say, folks, that we're going to be going through a project where this was done and it did work very well. Now, because you've gone through and been able to kind of get to the notional targets and the notional options that you should be considering, now you can get into things like sizing and system selection and major budgets and start to tie together both the building systems, their costs, possibly even their long-term costs, and then look at issues like life cycle carbon, especially with regard to embodied. Design development. Any comments from anybody from my partners on the schematic design? I think we've pretty much said it there, right?
Yeah.
Okay, good. Design development, again, now it's starting to become much more like, a building project that we all know and love. Because we've now steered things in the direction that we feel it needs to go, now you're in classic design development with one thing we'd like to discuss real quick because it's really important, and that is we really encourage that there is ground rules, especially with your client, with the decision makers, with regards to value engineering before it goes out on the street. I've heard, I've been in this business for a very long time. So have my partners in this. I'm sure we all have stories of how a really great idea died an early death because value engineering took it out of the picture. This is a real problem when it comes to these kinds of projects, and we need to be extremely careful about that. We could do a whole webinar on why VE happens. But I did want to open up to my partners. Are there any points you'd like to make about value engineering when it comes to projects like electrification and such?
I think just like,
sorry,
go ahead, Jan. Yeah, you can go first again.
I think thinking about the possibility of VE during the earlier phases is really important. And I've seen some architects, when they lead that process, they already have like a list that they're going to throw out there so that they can keep the things that they want in the project. Go ahead, Stefan.
Excellent.
Yeah, I think like this is why setting those targets and conceptual is so important, because it kind of puts everybody on the same page about like what the goal is for the project. And then when you start VEing, you can literally just analyze, okay, if we make this change, like how does that affect, like, are we still going to meet our target, right? And I've been on projects that did great through the VE process because we were able to sort of analyze like, oh, hey, this is actually a good cost savings measure. It doesn't kill our target. It saves some money. Like, let's do it. And then it's like another one is like, no, this is going to like blow us out of the water energy wise.
Right.
It's actually like so just making informed decisions is important.
Excellent. So in the interest of time, you get to construction documents. The whole goal here is everything you dreamed of in the beginning and you set your aspirations toward and you felt was the best idea shows up here, right? That's the whole idea. And the next step is to make sure it actually shows up in the ground. Let's move forward. So keep that framework in mind. We are going to be bringing it back. And we will be referring to that as we move forward. Stefan, I think you've got the next section.
Yeah.
I will, by the way, just folks who are in here for training, if you have questions or comments, you can certainly leave those in the chat. We are going to have a more interactive session at the end of this training session.
Yeah.
Thank you.
So thanks, Doug. so running scenarios with energy modeling. So we're talking a lot about setting targets, testing different things. You know, what is this energy modeling we're talking about though? And hopefully most of you had some exposure to it. And I'll say first off that I'm an energy modeler. I'm an expert in that field. Like embodied carbon modeling is something have less experience with, but is incredibly important. And I think there's a lot of analogs between kind of energy modeling and embodied carbon modeling. So it gives us the ability to predict kind of the embodied carbon that our building's going to have, and you know, it kind of follows a similar path of increasing complexity throughout the design process. But anyways, for those that need a refresher, you know, an energy model, you basically are providing a 3D representation of your building. And unfortunately, this representation we use for energy modeling is nowhere near detailed enough to provide any really embodied carbon info. It's kind of like we're looking at two different things. Things matter a lot. There's just a lot of differences kind of in what we're actually looking at. So I think we're far away from anything that can combine those two models together, unfortunately, but perhaps someday. So it includes basic assumptions about kind of what the envelope constructions are made out of, and some of the internal loads like plug loads, how many lights are on, and number of people. We look at HVAC systems. We analyze HVAC systems, and we predict kind of what the energy consumption of those HVAC systems will be, throughout a variety of weather conditions. And we actually use weather files that are supposed to be representative of like a typical year in a specific location. So it's really important, especially in like coastal California, to pick a weather file that's very representative of your site. And we have ways of even trying to shift these weather files to look at future climate, because the climate is changing, and we're trying to understand like not how this building will perform today, but how it will perform maybe in 15, 20 years down the road. Unfortunately, yeah, the ability to shift a weather file is a bit limited, and it's not going to account for like more extreme weather events we're going to have in the future. It's more of kind of like looking at an average on an average kind of changing basis. But we can go to the next slide now. So decarbonization through rethinking the building. So we have this model, we have this 3D representation of the building. Now we can start testing things. And this slide is a good example of showing like how we can compare kind of our modeled results to some kind of target. So setting a target, like I said, is so important. And how you set a target kind of will define a lot of how you analyze your building and how you approach the design of the building that you're building. So this particular project, it had a zero net energy target. So the idea is we wanted to use energy modeling to figure out what design is going to work based on some maximum amount of PV that we can fit on the roof. So we want a zero net energy building. We're fine with maxing out the PV. We can kind of pick different HVAC systems, different envelopes. We throw it in the model. We see kind of what the results are and how it compares to like our amount of renewables. So we can replace this kind of maximum PV generation. That could be this is like an EUI in terms of energy, but we can look at carbon as well. And so if we're looking at like buildings like total carbon, we need to account for like PVs and battery systems, because batteries, they don't save energy, but they save carbon because they can help us use energy during sort of greener grid periods, and help us do self-consumption. They help us use our PV better, basically. So it helps for carbon. And then there's other tools that help us set targets. Like I said, benchmarking, AIA 2030, MEP 2040 is a kind of a newer group that's doing a lot on the MEP side. They're working a lot with embodied carbon right now. But there's lots of ways to set targets. Energy modeling helps us kind of test different ideas against those targets. That's the point I'm trying to bring home. So next slide. So the shoebox model, just helping kind of y'all understand. The shoebox model is kind of doesn't actually always look like a shoebox, but basically what we're trying to say is that we have a simplified model. This is something we use in conceptual design for the most part. So it's like kind of the most simple version of our building that we can imagine that will still give us like actually useful results to make the informed decisions. Right. So it's not enough to predict like exactly like what our energy consumption is going to be. We're not at that level of detail. We just want to be able to compare many different iterations of our building with different kind of envelopes, HVAC systems, and compare like how those different options will affect the energy and the carbon of the building. So we can parametrically analyze things, and this example I have here is just looking at a bunch of different kind of envelope values, like look infiltration, wall insulation, roof insulation, and you can find that certain combinations of things together kind of do better than kind of separately. So so that's why parametric is kind of important, because we want to look at different combinations combined together, and then with cost estimating, if we can get a great sort of rapid cost estimating person helping us, we can find kind of like where's the kind of the best case scenario where we have kind of an envelope that is reducing our first cost of maybe our HVAC system, giving us a lower energy use. Right, so that's kind of that's the ideal situation to be in. And we'll talk about Indio in a little bit, which is a project where we did kind of find this kind of low energy, low cost example that worked really well. Let me go to the next slide. So squeezing performance from existing buildings. So I'm making a case for trying to focus on the envelope, especially in the early buildings. So the envelope has huge implications both for embodied carbon and for operational carbon. And part of the reason that envelope is so powerful for embodied carbon is that if you have a better envelope, you can actually shrink your HVAC system. And HVAC systems have a lot of embodied carbon. They're made of metal, which is the carbon intensive thing to build, and they have refrigerant that has a global warming potential that leaks out. So smaller systems can, picking a system that has less refrigerant, and then smaller systems that need less refrigerant can be a great way to like reduce your embodied carbon. Envelope components also, putting more money into your envelope, the envelope lasts longer compared to HVAC systems. It doesn't need replaced as often, assuming you're getting good stuff. So that's a improvement for life cycle carbon. So in the coastal California, we have a great climate too. So as you'll see on our Indio, the envelope kind of reduces the amount you need to use your HVAC system quite a bit, because there's a lot of natural ventilation, night flushing techniques that can be used to not even use your HVAC system. So focusing on envelope can pay off in dividends in many different ways, operationally and through embodied carbon.
Stefan, I wanted to interrupt because there was a question that was very topical to the slide just before, which was by one of our students here, Charlie Boyd. Why with BIM and other known modeled assemblies does energy models still use simplified representative 3D models? I think what he's can't we do this better? But I think the point here is you're trying to do it faster and get to smart strategies, not necessarily define the details.
Yeah, exactly. I mean, that can be a really technical question too. Like, and there's
we could do a whole hour on that question alone.
I'll say there's a lot of physics and like heat transfer calculations happening in the background, and those calculations just like to make sense of like a Revit model, it would just be very, very, very difficult. But there are people that are working on automating kind of the simplification of a Revit model into an energy model. It's called the Ladybug Tools people have the best working one that I've seen so far. So they're kind of like doing the hard work. They're letting the computer do the kind of tracing of all the walls and stuff, and like automating that. So that's faster. But there's like real technical limitations for why we can't just use a Revit model for an energy model. It just doesn't have the information we need.
Right. Plus, it would be incredibly expensive and slow to get the very, very quick answers we're trying to get to at the
Also
conceptual stage.
Yeah, also true.
Yeah. Okay. Thank you. If you could skip forward. Sorry about that.
Yeah. We can go to the next slide. Yeah.
Charlie said too.
Here's a great example of other benefits of kind of focusing on envelope, focusing on passive when you're looking to make low carbon buildings. So buildings with poor envelopes, they're tough for the electric grid. So passive solutions kind of reduce the peak demand of buildings, compared to just like putting in like a really advanced HVAC system. So this is an example of like a code minimum versus like a passive house similar building in a couple different climates. And I think you can see like both of these buildings were kind of modeled to be zero net energy, so they have PV systems that are like offsetting all the energy use in a year. But even with that zero net energy, basically a code minimum building, you have to put a lot more PV in, and so like whenever whenever PV is producing a lot, it's like way overproducing, and then at night you're kind of way producing because you don't have any renewables. So the PV, there's just a lot more peakiness happening, which kind of makes the duck curve, as David will talk about later, a lot worse. So building more passive allows you to have lower peak demand on your building. It allows you to have a smaller PV battery system, which makes your kind of electric use less peaky, which is great for the grid. And it also allows you to have less embodied carbon because PV battery systems, they have a pretty good amount of embodied carbon associated with them. We love them, but we want to make them smaller if we can, right? Next slide. Seeking out embodied carbon reductions. Yeah, so just wanted to talk more about embodied. So embodied is huge. The figure AA here, this is from MEP 2040, the study they just came out with a couple months ago. But on the day zero, before your building's even operating, there's a ton of embodied carbon impacts on the building. And MEP systems are already using 27% of embodied carbon on a typical building from day zero. So it's maybe a lot more than most people think of embodied carbon as like a structural or envelope thing, but actually MEP systems with their kind of metal and their refrigerants use a lot of embodied carbon on day zero. And then their embodied carbon increases quite a bit over time because they have things like equipment replacing and refrigerant leakage. So, after I think this is like 20 years into the building, the MEP system is now responsible for 53% of just the embodied carbon of the building. And then when you consider the fact that HVAC systems are like the highest energy using piece of a building, once you get to like the entire whole building life cycle of carbon, including all embodied, all operational carbon, MEP systems can be said to be used 73% of a building's total carbon, right? So, and the thing is, we don't always have to focus on MEP to reduce MEP because having a better envelope reduces your HVAC size, it reduces the amount it runs. So, these things are all kind of linked at together, which is why it's so important for us to like look at the whole carbon picture as a team and not siloed.
And Stefan, we're going to have to kind of turbo the next two slides to get us kind of into timing because we want to have plenty of time for open discussion.
Yeah,
sorry about that.
Yeah, no worries. So much great stuff to talk about. We go to the next slide, Q.
We're always ambitious when we do these sessions.
Yeah. So anyway, yeah, what do we recommend? So every client has their own kind of like capability of what, some clients have all the money in the world, they want to do everything they can, but some don't. And sometimes you go to a building and there's just like genuine like issues, like it's crazy uncomfortable because they don't have any insulation, they don't have an HVAC system, glare, they don't have enough electrical capacity to put in this new heat pump system they want or something like that. So I think like every project that's like a retrofit, and we're gonna have a lot more retrofits than new buildings in the future to meet our carbon goals. Just diagnose the existing issues, just walk through the building, figure out what's going on, because sometimes maybe they don't need a fancy new HVAC system. Maybe they just need like their operable windows to work properly. Maybe they're stuck closed or something like that. Second, like reuse, adapt what is there. So before you go out and buy a bunch of fancy equipment, maybe consider making passive upgrades to the building. Because a lot of times these cost trade-offs can be in the positive. It could be better to like make a building work passively, especially like in coastal California, than to go out and buy fancy new HVAC systems. And then for what remains, once we kind of get those first two underway, that's when we want to start eliminating natural gas, putting in all electric HVAC systems, getting in PV and battery systems. Right. And then for the clients that have the money, everybody's going to have to do this eventually, but we should do it in stages because those PV and battery systems and electric HVAC systems will be smaller for projects that have gone through the first two issues already. Next slide. And this is just a quick example of basically we had a building that had this. We were looking at it because it was too hot. It was a school building. It was way too hot. We wanted to look at two different kind of retrofit scenarios. One was just a passive only. We're just going to put insulation, low E glass, and the other one was just not do anything passive, but just throw in some air conditioners. And we found that air conditioning fixes a lot of problems, but it doesn't fix a bad envelope because we're still having kind of thermal discomfort issues in our energy model when we put in the air conditioner. But the passive solution actually made the building more comfortable. And it turned out when we got cost estimates, the passive retrofit was cheaper as well. compared to putting in air conditioning. So this is an example where I kind of had the best of both worlds. Passive, it was cheaper, lower cost, and it'll have lower energy use as well. Next slide.
So, I mean, to me, this was really exciting because an investment in envelope was far further carried to the goal than investing in air conditioning to essentially work against a bad envelope.
Yeah, exactly.
Right.
Exactly.
And the economics are very appealing to the owner. Okay.
And I think, and that's it for me. And I'm handing it over to
Me.
David.
Yep. Okay. Thanks a lot, Stefan. So I'm going to talk about some of the issues on the electrical side. And I think the first thing is, one of the key strategies if we're going to all electric buildings using carbon-free electric energy is storage is becoming a big thing. And the good news is that the cost of storage, similar to the cost of photovoltaics over the years, has been dropping. So years ago, I remember doing my first net zero project, and PV was like $10 a watt installed. Now it's like less than $2 a watt installed in a lot of cases. So batteries are kind of, because of EVs, I guess, batteries are following that same curve and the cost is going down, which is a key issue. So over time, they're getting more and more affordable. Next slide. But I think a key thing that I want to be talking about is just like you need to convert all your gas-fired equipment to electric. So that's, clothes dryers, to heat pump clothes dryers, water heaters, gas cooktops to induction, and heat pump heating, eventually going to electric vehicles and even potentially changing fireplaces to something like an ethanol fireplace. So there's actually a interesting fireplace that somebody's making that uses steam to create something that looks like a flame. Next slide. A huge issue on the architectural side, and I think, underappreciated and not always used well done, is using daylighting. So architects have been aware of daylighting and using daylighting for years, but I think one of the things that I see happening a lot of times is it actually takes a lot of expertise to be able to do it well, and having a daylighting expert is important. And you can save a lot of energy because you don't have to use electric lights during the day. But you could also, if it's done poorly, use more energy because you're overheating a building and have a lot more window area and creating a need for more electric heating in the winter. Next slide. And so another issue is, how do you reduce not the energy use, but the peak demand? So especially if you're electrifying existing buildings, you have an incoming service already. And as you start adding all this electric equipment to replace gas-fired equipment, the electric loads go up. And in a lot of cases, you can overload your service. And to get a new service, often creates a time delay in the project to get the new service. Sometimes you can't get an increased service. And the other issue is that you need to have increased wire sizes and rewire things and stuff like that. So there's starting to be a lot of really interesting equipment that's out there to help you to be able to put in this electric equipment without significantly increasing the demand in the building. And some of them you may have heard of is like, there's a couple companies making induction cooktops. Typically, you need a 60 amp breaker or 40 or 60 amp breaker to feed them. There's a couple companies making induction cooktops that you could plug into a 120 volt outlet and they work just fine. And the way that they do it is that they have batteries built into them. So when you start using more than one burner and the load goes up, the batteries kick in, supply the extra power, and then when you're done cooking, the batteries recharge. So there's lots of new technologies coming out with some really interesting equipment, and that's becoming a focus point of innovation in our industry. Next slide. Next slide. Thank you. So that's an area to watch and to have your engineers watch is what's going on in those areas. There's a interesting product that actually our team's been working with that takes heat pumps and does some what's the word? So smart things that probably we should have been doing all along, but haven't been done. Think about a refrigerator. Refrigerators actually a type of heat pump, and it's taking heat out of the inside of the refrigerator and dumping it out into your house, basically, right? And so in the summer, you're taking heat out of the refrigerator, dumping it into your kitchen, and then you're taking heat out of the kitchen with an air conditioner and dumping it outside, which is, if you think about it, like pretty wasteful because you're using that two pieces of equipment to get the heat out. What if you could just like take it all the way out of the building in one go? Or better yet, what if you could take that heat out of the refrigerator and use it to make hot water? Right now, you're using one process and you're getting results of both cooling the refrigerator and creating hot water. So there's a company that we're working with called Flow Environmental Systems that actually is able to do that, and the efficiencies that they are getting when they're able to use that rejected heat efficiently is 2 times what a normal heat pump can deliver. So it's really fascinating stuff and can make a huge difference in energy use and ability. Next slide.
I'll just mention that Flow Environmental Systems is, it's a partner of Prospect Silicon Valley, and David is part of these projects, and David is really closely tied to our organization. We will put a link in the chat to 2 really important demonstration projects we're using with Flow, with a single heat pump providing hot water heating and cooling, hydronic cooling. So it's really cool. We'll put that in the chat. Anyway, go ahead.
Okay, cool. I think everybody or most people have heard this. It was in the news last year that California reached 100% renewable energy for 132 days last year. So I think lots of people are starting to think, we have plenty of renewable energy. We're in good shape. We're well along the way, right? And that seems to make sense, right? Next slide. Wrong. So this is just something that I faked up. I had some of my staff run through some calculations. So to the left is the duck curve that a lot of people have seen that shows that, middle of the day, renewables are adding a lot of energy to the grid, so the actual demand on the grid goes down to zero. And so that's an example of like one of those 132 days where the grid got to 100% renewable energy. But on the right side there, that's a representation of what it would need to look like if you were generating enough excess energy during the day to offset all the energy use at night, which is where we're trying to go to get to 100% renewable energy 24/7. So zero carbon, in other words. And you could see there's a huge difference in the amount of renewable energy that needs to be generated between the graph on the left and the graph on the right. Next slide. So you could do that with, huge PV projects out in the desert somewhere or in the valley. You could do that with wind turbines, or you could do that with PV on buildings, like that slide in the middle. So I think, you could do either. The implication of doing huge utility installs in the valley or in the desert is that we're going to need to add a lot more transmission lines, which cost billions of dollars throughout California. So the more you could get it close to where you actually need it, the better. Next slide. And then there's one other issue that I think is important to talk about. I don't know that I know the solution to this, but it's important for people to be aware of as we're trying to get to this kind of zero carbon world 24 hours a day, 365 days a year. So this is a graph of kind of how clean the energy is on the California grid through the course of a year. So you can see January on the left, noon is in the middle going across horizontally. And then you go through February, blah, 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 to December. So you could see in like March, April, during the day, middle of the day, the grid's very green, which is that kind of the duck curve where the belly of the duck's getting down to that 0 point. And you can see in July and August, late in the day when the sun starts going down and it's been hot, the grid's really dirty. So that ultimately we're trying to make this so it's all green all the time. But the problem is, next slide. One of the things I see happening that I talked to some of the utility companies about, and they're just, I think, starting to really grapple with this, is that if we go to all electric buildings, that implies that all the gas is going out of a building, and a big place where gas is being used is for heating. And so if all the heating goes from gas to electric, that energy is going to drop onto the grid, and that's going to happen in the winter at night. So suddenly the peak demand isn't going to be in August. It's potentially going to be in January at 2 in the morning. So that's something at least for our whole industry to be considering. How do we solve that problem? Next slide. And so, one thing I think we're looking at is putting PV on buildings and batteries in buildings. So it's becoming a code requirement, and I think that'll kind of the requirements will become more stringent over time. Next slide. So the good news for architects is there's a lot of different ways that photovoltaics can be incorporated into buildings. So you can get very creative with them, both in the roof and on top of buildings, but also even in facades. And it's been done both in the US and in Europe. Next slide. And then the other thing is looking at batteries in buildings. That's starting to become a very big thing. And that slide on the right is a utility scale battery installation, and I think it's currently still the largest battery installation in the world. But there's more in California being designed and built. And then next slide. We're already starting to see large batteries being installed in buildings. So this is a project I worked on recently that was, it had 1.4 megawatts of PV, but interestingly enough, it had 2.5 megawatts and 5.3 megawatt hours of batteries to create a microgrid that this campus could use in case power went out, and also to kind of support it to be able to store power and use it later on in the day. Next slide. Shannon, I think this is you, right?
Yes, this is me. So I'm going to cover the 435 India Way project, which was previously mentioned. But so about 10 years ago at the firm that Dave, Stefan, and I previously worked at, we worked on this renovation project of a 30,000 square foot renovation of a 1970s concrete tilt-up single-story commercial office building, which is a common building type throughout the Bay Area and especially in the South Bay. The building had uninsulated concrete walls, really thick concrete walls, and concrete floor, wood roof, and single pane windows. And the goal of the project was to see if we could renovate the building to be net zero on a developer budget. And our first task was to set the maximum energy budget based on the roof square footage. It could be site square footage too if you're going to put in overhangs, but we looked at iterations of that too for PV production and decided that the roof was the best bang for the buck. So then once we had our energy budget, then we worked toward that budget by breaking it down into the different components, which you can see in these two charts here. And then you whittle down the different components where you can to try to hit that energy budget. And although this project was design build, it was very much integrated design, starting from the pre-conceptual level, even when they were looking at which building to use. And so that brings us to the next slide, which is the overall design phase tasks shown here that we previously discussed. We did, even though this project Indio was design build, we did go through all of these tasks. So I wanted to highlight here that the project delivery method shouldn't change when how early these tasks happen. It might be that a different team member is doing them, but they all ultimately do happen. Doug, did we want to say anything? Anybody else want to say anything about this one?
We just wanted to bring this back so you recall what we said not too long ago about the strategy that we're recommending you employ, because we're about to tell you how that strategy was employed and what it did.
Okay, next slide. So going back to the Indio example, we first focused on the building envelope. And here's an example table that we used for tracking the modeling inputs for the envelope and the interior loads. Hill House Construction was the GC, and they did cost exercises on a few different envelope options throughout the conceptual and schematic phases. And each option had to hit a max AC tonnage, which ended up being around 30 tons for that 30,000 square foot building. And that proved to be more than what was needed. Because one thing I didn't mention yet, but that project was replicable, and that was the part of the goal, was to create something that's replicable because there are so many of those building types. We also needed to bring down the daytime lighting loads. So we added numerous skylights to bring in the daylight to the dark internal space, because it's pretty much a square shape with no existing skylights at all. And so part of that energy budget was the lighting power density, and we were able to bring that down during the day by putting in all of those skylights. So when looking at, next slide, sorry. When we looked at the annual energy use in our model, and this is going back to something that Stefan noted about the building envelope, being able to reduce your overall air conditioning tonnage or system size. When you upgrade the building envelope and are able to employ passive strategies, you're also able to easily use like an adaptive thermal comfort range strategy with your temperature set points of your system, which also affects your annual energy use. So here, we didn't enable the cooling until the space got to 78 degrees. And this proved to be effective as the space rarely reaches 78 degrees. And that's due to leaving the thermal mass that was there, the concrete walls and the concrete floor, leaving that exposed. Because on that project, we put continuous exterior insulation and left all of that concrete exposed. So that really reduced our annual cooling hours by a lot. And then once we had the envelope dialed in and the HVAC unit sizes selected, we were able to dial in the rooftop solar layout and the production. And then comparing that against the final modeled building energy consumption. And that iterative process between the building energy consumption and production happened throughout all of the design phases from the very beginning. And then just throughout the design process, we just fine-tuned it and got closer and closer to what we could model as what reality would likely be. Next slide. So here's some before and after photos. And you can see that on the top photos of the exterior, on the right-hand side, it looks very similar, but that's all exterior insulation, continuous exterior insulation. And in the interior photos, you can see how much light the custom skylights brought into the space. So on that bottom right, there's no lights on in that photo. And there's a lot of other details about the project that we're happy to share. So just feel free to reach out and we're happy to chat about it.
I think it's also interesting. It's kind of evidence there in that photo that the HVAC was not very big. You're able to really downsize that. I mean, you see that just from ductwork alone.
Correct. Yeah, correct. So on the next slide, we're gonna play. Here's some. Oh wait, I already did that.
We're gonna try to play those in parallel. Is that what you wanted to do?
Yeah, we'd like to, because the one on the left doesn't have anything. So the one on the left is the components of the building systems coming together, so you can see in the animation, and then some pearls of wisdom from our project developer. Go ahead.
Yeah, I think a general takeaway to me for a building like this, if you're making the decision as to whether to renovate your building to meet minimum code in the traditional manner versus trying to do a renovation of this nature where it's net zero energy with the health and wellness aspects associated with it, what we have found is, as I mentioned before, we get about $3 back for every dollar we invest in the sustainability measures. So it's more profitable for the ownership. That's been demonstrated and proven. We have natural air, much higher indoor air quality, much better acoustics, uncommon thermal comfort, connectivity with nature 24/7 for the occupants. So you've got a much healthier environment for the occupant. Healthier occupants, there's a lot of studies that demonstrate that that means more profitability for the company. So our tenant is more profitable, so my credit strength is more reliable than it used to be. The lender now has a more reliable building that if it ever comes back to them has lower operating costs and it's a less carrying cost for them. So every angle that I look at a building like this, whether it's from the ownership, from the tenant, from the lending community, from the occupants that are going to be in it, it's a better prospect. And so we really are having a difficult time understanding, if you can do it this way, why you would ever choose to do it any way different.
So that wraps up the India Way project, and I do want to say that again, that this was we did this project approach 4 times, and it worked great, and we were able to fine tune the process each time. So really, when you're focusing on your approach to these projects, finding where you can replicate is really going to help you bring more of these home.
Right. So I think we should mention that was Kevin Bates from Sharp Development, who had been the driver of this India Way project. And I think was the person who was not only receptive to the kind of early strategic discussion and the kind of weighing of values and the setting of goals that Shannon went through, but also has gone on to be a really big champion of what you just heard, which is this stuff isn't just a cost and you don't just do it because it's the right thing to do. It can be very profitable and the building can perform extremely well if you emphasize the right things and make the right investments. So I think that's great. So we've got about 27 minutes. That's not bad. I'll just remind my partners I had emailed a set of topics. So you should have that available to you, but I wanted to just maybe open this discussion. We are going to try to get to some questions that were in the Q&A. I'm going to ask, we have an embedded student. I'll just say that Madeline from ProspectSV is actually in this session as well, and she's going to find the questions that we haven't been able to answer in the chat and just pop them into my Slack so I can make sure we got them going. So thanks for helping us in the background while learning. So first topic I wanted to kind of bring in. So we've talked a lot about, how we need to set a strategy. We want to build a team early and get the parameters kind of on the table all at once, and then start to set a path toward the rest of the project. But in this picture, just to remind folks what we may have talked about last time. Um, what's an owner really stressing about? Are they going to be stressing most about cost? Are they going to be thinking about OpEx? Are they going to be thinking about their internal priorities and standards? Are there what's going to be the most important areas to kind of play into? And I'm going to see if Shannon or Dave, you might want to open that discussion up.
Shannon, you want to start?
You go ahead. I have some
Okay.
that I'll add.
So I think, I hate to generalize, but I think there's big differences between types of clients, right? And so, a school district is different from a spec developer who's different than, somebody like Google or Microsoft, right? So I think some of it is understanding your client and starting to understand what their issues are, and then being able to talk to the things that they're concerned about. So I know in some cases there's, international carbon standards that companies need to submit, what they're doing, and it's a big issue to them. But, that's for big multinational corporations. For a school district, that's not an issue. But then, if it's a public school, then
But there could be other
state,
concerns with the school district, right? Including
right,
students
absolutely.
themselves, right? As we've heard many times, that students and parents, they want to see these features in their schools, even if it's not the policy of the school district themselves. And pressure like that can create a major issue. So that establishing conversation of what are the rocks about to hit their head, so to speak, not to be gory, but what are the things that are going to really be driving them beyond just the classic building project is really, really important. Shannon, did you have some thoughts on that?
Yeah, I think so. I've seen the first cost and the ease of operation being the biggest one with school districts, especially lately with the ease of operation and maintenance teams getting pretty small. And then the Indio case, leasability I feel like that was the thing that Kevin was most skeptical about, was the leasability. It wasn't really the fact that could we do this? Yeah, of course we'll find a way to do it. But what's the leasability?
Right. And it turns out it was that wasn't a
That
question.
was not the issue.
Yeah. I mean, Kevin's
It might be
talk about
interesting to hear from some of the architects in the audience, like what things that they've run into, right? That what hot button issues they've seen that they're not sure how to deal with.
Okay, why don't we get to that in a second, David?
Okay.
I want to make sure that we stay on track.
Okay.
We are going to have time. Thank you very much. So anything else about kind of what the owner might be stressing about? What we're getting at is here, you want to have this meeting, you want to talk about the goals, you want to set metrics. What's the owner bringing in to the room? Was there anything else we should bringing up there?
Shannon mentioned maintenance and stuff like that, and that, kind of maintenance staff and how things are maintained with different groups, it is a big issue, right? Do the systems need to be simple? Like BMS systems sometimes are horribly complex, and then it's really hard to keep them working. And so I think those types of issues is important to be aware of. I know I'm doing some work advising the Cal State University system, and they own their buildings for decades and decades and decades, and so replaceability and kind of longer term issues are at the forefront for them. They every project they're looking at, hey, what happens 20 years from now when the equipment fails? How do you build things so they last?
Okay, so if that's what the client is bringing, or the owner is bringing into the room when we're having this early conversation about the carbon strategy for the project, you all have done some really incredible work, and Prospect Silicon Valley has done some incredible work getting people to take chances, right? How maybe you can share some of your experience in how are you getting a client to think differently, and also I'm gonna bring in the topic of, is this about trying to convert everyone, or is it about hooking into people that get it? But let's just start with that idea. How are you getting clients to think differently and take a chance when it comes to some of these measures that are going to help them get to the goals they want to obtain?
So for each project, I generally don't try to convince anyone of anything unless I can feel that they're receptive to it. But instead, I look at how can I get my measures into a project with this group of people? And I learn what's important to each player and what makes them nervous, and then kind of cater my approach to those like personalities, I guess.
Right.
I
David?
think certain clients can be receptive to like soft benefits too, Shannon. I think Shannon, like a good example for projects we've worked on is like the radiant systems that we've kind of had put in. There's a lot of like soft benefits with like comfort, or like it works really well with like indoor outdoor spaces. So I think we've managed to get kind of like a system that's inherently more energy efficient and very, operationally carbon efficient, but selling it for kind of the other good benefits of it as well.
Yeah, that's true. There, a lot of times you'll see that you'll bring something up and it's something that the client hasn't thought of, and then they do learn that, oh yeah, this is important to me, or this is important for the project.
Yeah,
Right, but just telling them it's important. Anyway, David, go ahead, and then I'm going to come back to Shannon.
I think it's a couple things. One is, we all have our different specialties. And, I would love it if every project was net zero energy, but it's not always going to work like that. And so one thing I think is important is for all of us need to be able to play well with the larger team, right? It's not like my stuff is more important than everybody else's, or Shannon's stuff is more important than everybody else's. So there's been plenty of projects where something else was the biggest issue for a specific project. Like we did this really interesting project with Microsoft, and a big focus was on water and water treatment and stormwater and things like that. So, it's not net zero energy, but there's some like groundbreaking stuff that was done on it that other firms could study, go away, use. It will make a big difference in the industry. So that's one thing. But the other thing that I think is hugely important is kind of the conductor of the orchestra, as it were, is the architect generally. And so kind of the architect really needs to pull everybody in and lead that effort of getting those um, key concepts, strategies, goals, etc., on the table early on, get the owner to buy into it, figure out if you got enough money to do what you want to do. If you don't, what are you going to do? and kind of set all that up early on so you have a framework to work within. And the projects that I've worked on that were really successful, that, you know, usually the architect, and sometimes the client, but that was done early on in the project. So there were some things that we knew we were trying to do, and able to spend some time figuring out how to get there early on in the project.
So I will just say that I'm looking at the chat, and we've developed the perception, at least among one audience member, that this process is expensive. And that was a point that Shannon, I think could emphasize a little bit more with India. Did it cost more to do carbon analysis? Did it cost more to focus on the essential performance factors?
No, because we had a consultant budget that we had to hit, and we knew what the project goal was, the goals were, and then we catered our scope and our approach to that. So they had, on the first iteration, I think it was $80,000 for MEP, and we were also helping to lead the project because we all worked to hire the architect. We interviewed architects with the developers.
Mhm.
So, and it was design build, and that's how we decided it has to be design build because our fee has to be low, and most of our fee has to go to modeling with just very little for MEP, like actual systems design. And then the second iteration, we got that fee down to 60K. And then I think the one after that was probably like 45 or 50, and we stayed right around there because we did have like modeling to do on each one that's specific to that building.
You're talking about subsequent buildings.
Yep, that's why I was talking about replicability.
Right.
So that first one, you might spend a little bit more, and then it's just something that each team has to work on. Like, how are you going to set that design goal, that fee, and work within that to hit your target, as well as any requirements of like, oh, you have to do conceptual SD, DD, CD, C8, you have to do the whole thing, or can you modify your delivery approach so that you can fit in all of the modeling that you need? So it just takes some additional thought to try to avoid the excess design fee that you're thinking it might cost.
Right.
And Doug, honestly, that's one thing where Stefan using shoebox models and things like that, it's like, do the amount of work that's appropriate to do early on in the project. So he didn't get into the weeds on all the nuances. He just looked at, okay, I have this at a very high level. Here's the things I can look at. This will have big impact. This won't do anything. So let's focus on these things. And then working back and forth in this case with the contractor of, hey, we can do this or we can do this.
Right.
You know, this one's better, but whatever. And then they'd say, this one's more cost effective. And then that's the way we did it.
Right. So we're bringing, again, this is really important. And I don't think I'm telling anyone in this session something they don't fundamentally know, but clients will react better to evidence and data, and frankly, an example of how it's worked elsewhere, more than they will any kind of compelling salesmanship to take a chance on something that looks good. Right? So nothing we're talking about here was convincing somebody to go spend more on design. It was the challenge of meeting a reasonable design budget and even being able to provide the advantage of a declining design budget for multiple projects by focusing on some of these things very early, creating the evidence and creating a sense of confidence in the decisions being made, and then locking them in and not allowing those solutions to be somehow distracted or replaced, or in other ways let that momentum be sapped, right? So incredibly important, and that kind of partnership is really important. Now, you know, in the world of Prospect Silicon Valley, where we're taking solutions and trying them many times for the very first time, like with flow environmental systems, a system it performs extremely well, and we know it performs well, but it needs to go into buildings so others can see. being able to partner with clients that are allowing us to install this system in a very, very critical facility alongside their existing systems, and then working with them to both monitor and improve the performance of that system and show how that will actually create an advantage for them. It takes mountains of evidence and conversations and risk sharing for that kind of work to happen. But the more you can, again, upfront, really kind of nail in where those goals are and nail in how these solutions can create an advantage, and then bring them a team that's going to continue to support them and respond to their needs, I think is incredibly important. It's not the classic prime sub type relationship. It's a team that's surrounding the leader and making sure they're always there for them, right? So, along those lines, what does team building look like in the picture we showed and in the approach that we're showing? For all of you, for folks that are here to hear your expertise, what does team building look like at the conceptual stage that may look different than a classic building project? Now, we all talked about this, guys, so I'm going to call you out. You know the answer.
You
What does
know,
team building look like?
a little bit in my case, in our case, I feel like we're cheating because I've worked with these guys and these teams, and I've worked with some of the best. I'm really lucky. I've worked with some of the best um, energy designers and system designers in the country, hands down. And I feel like there didn't need to be a bunch of team building because people that are really good at this, they just know how to play well together. I don't know how else to describe it. It's just like, people check their egos at the door, and you sit down and have a frank discussion of, I can do this, and this thing's, you know, this will have a big impact, this won't, and people are willing to step back when something else appears to be like more efficacious or whatever. But like I said, a big part of that is the thing that I noticed on the architectural side is um, that needs to be supported by the architect because, like I said, they're the conductor of the orchestra. And if they're not trying to actively pull in, hey, what's the energy model say? If we do this, we're not going to do that if the energy model says that's a bad thing. And how can we get the most efficient systems in there? And we need some renewable energy on this project, et cetera, et cetera. If they're not backing that, it's not going to happen. So it does need to be a team. The team needs to be knowledgeable on the things that they do, and then they need to be able to figure out as a group what are the priorities and then stick to them, right? And I always joke about one of my mentors and a great engineer I've worked with in the past is Peter Rumsey, and you know, he would be able to go into a presentation and convince the architect and the design team that, radiant floors, which is, like concrete floors with pipes in them, is like more important and sexy than granite facades or granite in the lobby or stuff like that. And there's a lot of money that's floating around as buildings are being designed and discretionary places that it could be assigned to. And so I think, some of that is kind of setting the priorities and then assigning them and then trying to stick with them.
Right. So, and y'all have your notes, so you're going to remember we talked about this. What you just said there, what we've heard about is, you're knocking out the bad ideas and you're moving with the owner's feedback toward, what they can buy into, right? But you're giving them data and evidence, and you're giving them the information they need to feel confident in committing to a decision or committing to a trade-off, right? So, one of the things, and I just want to get your all, confirmation here, if the architect is a leader of this team, the team that leader needs to truly understand the team they put together, what they're capable of, and use that whole team's voice. What does that look like for you as somebody that's been on a team where you've been able to play that role? I mean, Shannon, David, with Indio, what is it like to make sure that your voice is very clearly understood by the lead?
So it was that project experience was really awesome for me because I was like a mid-level engineer at that point, and I was listened to by contractors and developers, and everybody that was on that team was talking about other disciplines things. We were all talking about everything. And I wanted to say, going back to what David was talking about, the Indio project was special, and all of those other ones were special because it made it exciting doing a different like team structure and start to a project. So it was really fun to engage with everybody. But even on just standard projects, like there's a K through 12 project I'm working on right now, and it's pretty standard, but it's more exciting than the normal ones because the architect is bringing everybody to the meetings early, and we're all talking and we're all listening to each other and hearing things that you wouldn't normally think, like, oh, I have this interaction with landscape that I didn't think that I had, but because we're all talking about our individual scopes and how they interface, you get that team feeling more than when whoever's leading the project is keeping the people siloed and having separate breakout meetings. It's fine to have separate breakout meetings, but you want to have that one big overall one where everybody gets to talk about their scopes.
Excellent. Okay, I just want to hit a few participant questions. We hit several of them in the chat, but a few that we could hit. So one was on the topic of embodied carbon on the MEP side. There was a comment that it would be better to show in future presentations or future training sessions that you break out where the embodied carbon is amongst the MEP, which is a fair comment. But just for everybody could know, the amount of the embodied carbon in the MEP that is taken up by refrigerant is really significant. And maybe if you could make some comments, Stefan or Shannon, on the embodied carbon of a refrigerant, even relative to the embodied carbon of everything but structural.
Yeah, it's significant. I mean, I'm looking at the MEP 2040 guide I'm looking at, and just keep in mind, like, this is like it's being updated all the time. They start with like a kind of a small selection of pilot projects, and they're adding more projects where they're getting more data. But it's like the refrigerant, like, lifetime embodied carbon for this one example is like 60% of kind of the initial product embodied carbon. So if you think of the initial product, like all the steel and everything kind of being put into the building, that which has a fairly big footprint on its own. It's about 60 to 70% of that is just from refrigerant leakage. So it's significant.
Yeah, I mean, one of the reasons that we're working with Flow, besides the fact that you can replace multiple systems and it has an incredibly high coefficient of performance, is that it's using CO2 as its refrigerant. So the embodied carbon advantage is extremely high. Is that when you think of embodied carbon and refrigerant, are you trying to emphasize that in early discussions?
Yeah.
Yeah.
I mean, we are. Yeah. I mean, Shannon, you can talk about that more
Yeah.
than me, but yeah.
Yeah, I do in the system selection, where if split systems come into the conversations, like an example in there is keeping your line lengths short, so you can just keep your overall pounds of refrigerant for the system low. So that from the refrigerant side, I pay a lot of attention to the pounds of refrigerant on the product, because it's hard right now. It's hard to get away from like R32 or 454B, because CO2 just isn't there yet.
Yeah.
As far as the
Which we
amount
could do a
of
whole other
equipment.
session on.
Yeah.
Just
Yeah.
that alone.
Yep.
It's very tough. Okay, yeah, great. Just another real quick question. We only have a couple of minutes. David, when you were showing your slides of kind of the usage patterns over day and night over the year, you remember your red, yellow, green map, right, Dave?
Right.
Okay. You were talking about how when heat pumps are employed, when we start to make heating all electric as opposed to being natural gas, that electric demand picture, you can start to see winter peak and not just summer peak, right? What about EV charging at night? Is that becoming a significant load factor for nighttime energy demand?
Sure. But think about it. Why do people charge their EVs at night?
Because
Like
it's
late at
cheap
night? It's cheaper, right?
and because they're not driving.
So as more and more PV hits the grid and we get too much energy at noon, what's the cheapest electricity going to be in
Yeah.
the future, right? At noon, right? In the summer. So, some of it is the rates haven't caught up to the reality, and maybe some of it is the reality is still evolving, and there's a lot more PV that needs to be installed, but rates being cheapest at night may not be the case in a few years. So I think that's a key thing.
Right.
But EV charging, of course, is a huge thing, because if you think of all the gasoline that's being bought and combusted right now, if that all has to be electricity, and actually it doesn't all have to be
We only have 30 seconds.
electricity, but I think that's a key issue is all that's going to have to come from the grid also.
Excellent. So one last thing, and I'm really glad that Allison asked this question, because it's a point for this team to actually show other work that we're doing. How can we make these things work for communities, disadvantaged communities, and those that aren't gonna, be the high rent, they're not going to be the high rent commercial project, or they're not going to be the big food production facility or otherwise. We are working, Prospect Silicon Valley and partners like Alter and like David at AIASF are working on solutions, technology solutions, and design approaches that will take high value, high dollar type systems and make them work economically and expand the benefits for those that and for those projects that are not going to be what you would consider premium projects. So affordable housing, small buildings, especially small buildings that are older and not in as economically advantaged locations. The solutions we're talking about and the direction we head are to make the economics work for those projects and to make the advantages outscale for the costs we do. We're very proud of that. Again, I'll just ask Q or Madeline to put the link to the Pathways program. There's multiple projects we're doing in that space with power management systems and others, where in works that we have in the hopper that are going to be aimed directly at expanding the economics for these projects to those that aren't just the high dollar amount. I
Hey,
think oh
let
yes,
me
please.
jump in for 1 second. Alice, Doug is working on, and we're working with him on 2 projects specifically that are attacking that issue with low-income housing and solutions to how to electrify low-income housing. So that's a big issue at the state level, and there's some interesting stuff that's happening that hopefully will help solve that problem, or at least attack it in a meaningful way.
Thanks, David. Let's talk afterwards.
Excellent. Well, with that, we've taken the time that we had asked of you. We really appreciate that everybody came to this session. We will be holding more of these sessions. In our plans, will include a deep dive on embodied carbon and aspects of embodied carbon that perhaps designers are not thinking of, or opportunities that are there. We're going to do the same thing about operational carbon, although it's not always what is front of mind in a new building project. The operational carbon aspects are becoming incredibly important to the economics of the overall project, and we'll be taking a deep dive there. We'll continue these carbon strategy sessions. We would love for you to share with others that these sessions are going on. And to stay in touch with us at ProspectSV to learn more about these opportunities. Our thanks also to AIA San Francisco Committee on the Environment, and Charlie Stott and Mark Kelly for their leadership and helping us be able to set these off. And to my partners here, really appreciate all of your efforts, and we'll look forward to more great times in discussing these issues.
Thank you.
Thanks.
Thank you all. Have a good day.
Thank you. Bye.